And this actually shows a sneak peek here coming from James Webb Telescope with regards to a really close by star that is really young, and how this star here is evolving in its size in such a way that it's going to look somehow like our own particular sun. And this particular sun here, according to we have in this article here, it says that it is a young star that is going at a supersonic outflow according to this description here in the title. And here is a newborn star that, if you look at it closely, you will see some interesting characteristics of what it is like. Mainly one, in terms of how the gases are spewing in both poles of this sun. That is one big thing to keep in mind. Another big huge thing to keep in mind about this particular sun is that it is around a few tens of thousands of years old in this particular shot here. And so when you look at this particular region where it is relative to Earth, it says here, according to this article, that it is around 1,000 light years away from Earth, and it is the youngest and the nearest object of its type. And now, thinking about the types of things that this is classified at with regards to young stars, this here is known to be called the Herbig-Haro object, and this here specifically is called the HH211 compared to the other types of the Herbig-Haro objects. And so, in terms of the description on how this object is and what it is in details, it says here that this here is created when jets of gas from these newborn stars form a shock wave as they collide with surrounding gases and dust. Now, this web here, according to our particular telescope here, which is very incredible to see how it was able to capture this in full detail here, actually shows a sensitivity in the infrared vision. And this here shows the dust and the gases that are present here, and how this here is resulting from the heat emissions from the star's outflows, and this mapping out the structure in unprecedented detail here. Now, it's going to be interesting to see how many more investigations is going to be diving into this particular location in terms of the HH211 and other HHs that are actually out there in our own Milky Way, or maybe outside of our Milky Way. Now, in addition to this particular information is the specific type of gases that are actually present in this particular gas dust combination that we see in this image. One is, of course, the presence of molecular hydrogen here. We also have most likely amounts of carbon monoxide, and as well as silicon monoxide. So it's going to be interesting to see how this here is going to be a kind of a blueprint in terms of the origin of suns or young stars, and also our understanding of how this can lead to an interesting look into nuclear fusion, if you're thinking about it that way. So really wonderful to see this particular results here that is coming based on this image from James Webb Telescope. So I suspect, of course, it is in the near infrared spectrum here. Now, another incredible information here is with regards to how James Webb Telescope actually reveals an outflow of the class 0 protostar, in this case here, which is an analog of our own sun when it was no more than a few tens of thousands of years old, and with a mass that is only 8% of the present day sun, that is our own sun. Now, in addition to this particular information here, it says that this particular web reveals that it is roughly around 5 to 10 times higher spectral resolution in terms of the image look here than any previous image. Now, there are many images of it out there based on our ground telescopes that we have here, but in terms of how this here shows the complexity of this particular image is pretty fascinating, not only in terms of how relative it is, as you see here in terms of what researchers are saying, which regards to it says that researchers have used the Webb's new observations to determine that the object's outflow is relatively slow in comparison to more evolved protostars with similar types of outflow. And there is one that we had of James Webb Telescope that kind of looks like an hourglass, and that one here is going to be definitely undergoing more investigation on how that will lead to the formation of a star. But in this case here, this is going to be a different take on how stars can actually develop, mainly suns, and going to be incredible to see what the future holds in terms of this particular results right here. Now, it says here that the team measured the velocities of the innermost outflow structure to be roughly around 48 to around 60 miles per second, which is roughly around 80 to 100 kilometers per second. Now, however, the difference in velocities between those sections of the outflow and the leading materials they are colliding with, which is in this case the shock wave, is much smaller. And so the researchers concluded that outflows from the youngest star, like that in the center of the HH211, are mostly made out of molecules because the compensatively low shockwave velocities are not energetically enough to break the molecules apart into smaller atoms or ions. So overall, I hope you found this really informative about this particular young star that is not too far away from us, and how this can show some incredible parallels with our own sun and how it evolved to where it is currently. Hope you found this really informative. Hit a comment down below. Let me hear your thoughts about this. But that way we can talk to you soon. Stay smart as always and believe in yourselves.